Firecast, a podcast from MDM Publishing, brought to you in association with International Fire Protection Magazine, the global voice for passive and active fire protection.
Welcome to another Firecast, where we get to discuss some of the key issues with the big players in the fire industry. I'm Paul Hudson, and today on the Firecast, we're joined by Jason Busalacchi and Andrew Biehl of TLX Technologies, an engineering and manufacturing company that designs and produces linear actuators and solenoid valves for the global fire suppression market. We're going to be discussing TLX's newest product, an Explosion Proof Actuator with Supervision to be used for actuating fire suppression systems located in hazardous environments. So in our conversation with Jason and Andrew, I'm aiming to find out why TLX's actuator for hazardous locations is different from other existing solutions, some of its unique design features, how simple it is to implement into your system, and also how this new product meets HazLoc, ATEX and IECEx regulatory standards. So Jason and Andrew, thank you for joining me on the Firecast today. Can I just get started with some basic information about the new product? Maybe Jason, you join me first and tell me what makes this device different from other actuating devices produced by TLX, and why did TLX see the need to develop this product when there are so many other solutions currently available in the market?
First and foremost, the device itself acts as its own enclosure. So with a lot of the systems that were being put out into the market, they have to cobble kind of together componentry that might be of maybe some sort of standard location device, but they would have to wrap around an enclosure as to contain any media that might have propagated into there. Well, instead of having to use multiple different components, our actuator itself acts as the actuating device and the enclosure all at the same time. Besides that unique feature, the other thing that sets us apart from anything else is that even with the industry, it allows for, just like our other actuators, it allows for only one leak point within the actuation device and the system associated with it. So essentially, the only leak point that you're going to see in using our device is just the one that's in the discharge valve itself, which is the check valve or Schrader valve, as you might call it, that our firing pin associates with. Otherwise, we still adopt the supervision for NFPA, installation supervision. So anytime that maintenance or installation personnel remove the device from the system, there's an audible visual signal at the control panel letting them know as such so that it gets affixed appropriately. And then one of the other unique design features I would say is that it's modifiable to the operating pressures of the system. So we can adjust our force outputs as to whether you need maybe 12 pounds of force on the Schrader valve to open a 25 bar system, or up to 112 pounds or 500 newtons, depending upon the company you're working with, to open a 300 bar system. Because what we don't want to do is we don't want to apply 110, 120 pounds of force to a discharge valve's check valve that can only withstand 30, because what we don't want to do is we don't want to damage the system. So it allows us to be modifying the internal componentry to adjust to any of our customer systems. So basically, you could have one device and put it on 3 different systems, and we can adjust the force outputs to be, from, if our customer has a 25 bar, a 50 bar, or an 80 bar, or even a 300 bar, we can utilize the same essential core device across all platforms.
Thanks, Jason. Let's bring in Andrew Biehl now. And Andy, explain to me some of the unique design features that you've incorporated into this new actuator and how these features offer advantages over other competing products.
The 2 main focus points of this design are, one, that it's built on a proven technology that TLX has already designed and used in multiple applications, and 2, the integrated enclosure. So starting on the first point, as Jason said, this is very similar to many of our other fire protection products, as it's mounted on top of a fire suppressant tank with a valve, typically a Schrader valve. So when the control panel sends a signal to our actuator, it causes a firing pin to fire and actuate that traitor valve, causing multiple other stages to fire and releasing the fire suppressant out to the system. It can also be actuated via manual override mounted on top of the actuator. Many of our existing customers will find this familiar, as the fundamental operation of the device is identical to our other actuators. So it'll be very easy for them to integrate this valve into their systems, anywhere from a low pressure system up to a high pressure 300 bar system. Really, the unique design feature of this actuator is having the hazardous locations enclosure integrated into the actuator. It's not another part you have to add on. There's not additional sourcing. You just buy this one part with the actuator and the enclosure, and it's fit for a hazardous environment. In particular, it's used for all class 1 groups, which is essentially hazardous locations that have explosive gases or vapors in the atmosphere, and it is designated as flame proof. So what this means is that all the joints are designed on the device to prevent flames that start inside the actuator from, say, a short or some sort of malfunction from escaping out into the environment and causing an explosion that will harm others or other equipment. Once a signal is sent from a control board, if there's any sparks or a short or some sort of malfunction of the device, it'll prevent any flames or explosions that happen inside the device from escaping out into the atmosphere due to the gases propagating into the device. And a couple of the design points that make this flame proof are the lengths of the joints, the diametral gaps, as well as thread engagements and tolerances. So all of our cylindrical gaps for stuff like the firing pin and the manual override pin all have lengths at a minimum of 1.25 inches. That's a standard set by UL, CUL, ATEX, and IECEx. They also have a diametral gap of less than 4 thousandths of an inch, which is also set by those same standards. And then the other type of joint that's in our actuator is a thread joint. And the two main things they look at for this are thread engagement as well as the thread tolerance. So we meet both of those requirements for our particular thread on our device. And all these combined help make this enclosure flame proof, along with the fact that when they do the explosion testing, they measure the exact pressures produced by the explosion for our size device. And they test this at 4 times the pressure for a hydrostatic test, which tests the strength of the enclosure to make sure that when that explosion happens, the enclosure isn't going to explode and fragment as well as ignite the atmosphere. Along with that, we have some environmental ratings, one of which is designated by the hazardous locations. That's a type 4X rating. It's very similar to a NEMA type 4X rating, and that's designated per UL 50E. And then the second rating is a IEC rating, IP rating of IP66. Essentially, what both these ratings are saying is that our device can be used in both indoor and outdoor applications in pretty much any environment you can think of. The type 4X rating covers areas that may have ice formation, so the device will still work after ice forms on it and it's thawed out. And it also covers additional corrosion protection that's not covered under just type 4. Then the IP66 rating, which many people may be familiar with, deals with water and dust intrusion. So we're covered to meet a broad range of environmental locations, allowing our customer to put this in many different systems and many different areas around the world.
That's a pretty impressive list of features there, Andrew. Explain to me, how did you come up with them? How did you decide what you needed to actually include in this?
Yeah, so we've actually spent probably over a year working with UL, going through every single standard that we need to meet. It's a list of about 6 or 7 standards covered by UL, CUL, CSA, IEC, and CENELEC EN. And essentially, we've picked out the parts of those standards that were applicable to our actuator. So those standards have a lot of parts that don't really apply to us. It's more for things that are just enclosures that aren't an actuator with the enclosure built in. So we've worked very closely with UL to make sure that we've covered every single base we need to to make sure that this can be safely used in all hazardous locations.
Now, of course, the key thing whenever you produce a new product and people are going to want to know about this is that it's properly tested and then it's certified as well. So tell me about the testing regime and the regulatory certifications that TLX has been awarded for the new actuator.
Basically, the listings that we went through were mainly the UL and CUL, which is HazLoc 1203 for the UL standard for explosion proof devices, as well as ATEX, which is the European standard for explosion proof devices, and then an international standard, which is the IECEx standard. So basically what that allows for is that our testing has covered, with the exception of a few countries that have particular approval standards associated with them, we are qualified to send these parts with our customer systems in almost any country in the world. And that's really what we were targeting, as well as being compliant to the current NFPA standards for actuating devices on fire suppression systems. We have the ability to not only modify the interface to connect to the discharge valve that's associated with our customer system, but we also have the ability to modify the internal componentry. So basically, all of the externals and the outer profile will remain the same, whether we put it on a 25 bar system or a 300 bar system. What it allows us to do under our UL file, however, is to provide the force outputs that you would find on our lowest force actuator at, say, 12 pounds, and then scale the internals up to provide 112 pounds of force, or roughly 500 newtons, to actuate a 300 bar system. So what we wanted to steer away from is providing just one product that would open all of the discharge valves under different operating pressures, because we're providing a set amount of force. And so what it allows for is to ensure that our customers, if they get an actuator, they're not going to put 112 pounds of force on a Schrader valve or a check valve that might be only able to withstand 30. So we won't have to worry about damaging the system so long as we know the operating pressure and the force requirements required to open their valves.
Let me bring in Duncan White, who's group editor of MDM Publishing that publishes international fire protection. Duncan, I always like to bring you into our Firecast to get the real expert view from within the magazines. So what do you make of what you've heard Jason and Andrew talking about today?
Thanks, Paul. Well, as with all TLX products, we're seeing quality and reliability coming in, and I'm sure this has been driven by the customer and the end user to see something that can be put in place within areas where the atmosphere is unstable and we need that spark protection. So I'm sure that this is another product that is added to the TLX range, which customers will be more than happy to use. This is exciting news for customers across the world, and I'd be interested to know from Jason and Andy is when will customers be able to purchase this product or get their hands on and have a look at it at an upcoming event?
Well, essentially, because we've completed all of our required testing, it's ready for commercialization at this point. Obviously, at the system level, our customers will have to go through any range of tests that are required from the agencies to have this particular device included in their files. But through some of my work with UL along the way, it seems like the inclusion of this actuator is going to meet basically the same requirements that would be if you were to have wanted to include one of our standard location actuators into the system. So we've allowed it to, in its design, provide ease of adoption to the fire suppression systems that our customers would have. As far as being able to get their hands on it and maybe even see one in its tangible form, by January, when we begin to hopefully go to trade shows again, such as the Intersec in Dubai and the Interschutz in Germany next year, we will have physical parts on display to be able to speak to our customers that are interested in adopting this technology into their fire suppression systems.
Yeah, so we're very excited to bring this to the market. We've had lots of inquiries from customers for a range of different systems, even before we started this process. This has kind of been years in the making. We've had inquiries about this kind of device for years from customers that already have a system implemented, but it's not a particularly refined system. They have a lot of issues with it, or it's very expensive and complex. So we're very excited to get this into customer hands.
It's very exciting to hear about a product that's actually really been developed clearly off the back of a demand in the industry. And it's going to be really exciting to actually see it when we get back to physical events and actually really get to understand all that it can do. That's it for this latest Firecast. So thank you again to Jason Busalacchi and Andrew Biehl of TLX Technologies, and of course to Duncan White for his contribution. Join me again soon for another Firecast. Thanks for listening.
Firecast is produced and presented by Paul Hutton and is an MDM publishing podcast in association with International Fire Protection Magazine.